And now model 3, the last model. Here I'd really like to explore with you some potential mitigation strategy that can support the development of a blockchain privacy compliant solution. And so the question I would like to address with you, how to become privacy compliant and which are the privacy friendly technique in a blockchain environment. Some of them, of course, because we're not gonna see all of them, also because they are ongoing. So briefly, I would like to to explore some design option for data privacy of blockchain solution, and so turn our attention to a possible solution to the problem of reconciling the GDPR ethics with the blockchain systems. Now, how to become privacy compliant? Let's start with this question. So, first of all, the transparency and immutability issues that we've seen and that we know are associated with both public and private platform can to a large extent be addressed by implementing privacy by design measure. That's something that I would like to say. But there is not single blockchain solution or set of solution that can solve all the issues that we have described today. The solution to adopt really will depend on the technological capability of a particular blockchain, on the specific outcome of that use case. So we're going to see some interesting privacy-friendly solution, but they really need to be discovered and they need to be analyzed on a case-by-case analysis. And so, first of all, considering the key tension that we've seen and that can potentially affect blockchain user, we need to understand how to handle data privacy in a blockchain solution and so be compliant with the applying laws such as the GDPR. And so what I would suggest is to really look at the potential issues, the risk, in order then to develop the right solution. So what could be important is to have a data protection impact assessment before implementing any blockchain solution. And in order really to calibrate then the blockchain solution on the outcome of the risk assessment. So first of all, it is important to assess the impact of data uses, the impact of data uses and also the potential positive but also negative consequences. Recognize the mitigation measures at the early stage in order to limit the negative consequences, determine which are the level of risk based on the probability of negative consequences. And of course, the higher is the risk, the greater is the need to have policies in place and to have also training and verification. And then of course, this assessment needs to be subject to evaluation and to continue monitoring. Through the risk assessment, it will be possible to have a vision of the nature, the context, the purpose of the blockchain data processing, including how data is collected, how data is stored, is used. For example, if you talk about children data, patient race data, or whatever, which is the volume data, if there are sensitive data, for example, the nature of relationship with the individual, because the more there is a relationship, the more there is the risk. Which are the outcomes for the different actors involved. If we talk about supply chain, for example, which are the outcome for brands, for manufacturers, for consumers, or for all the different stakeholders. And so assessment should show evidence of consideration of any less risky alternative that can achieve the same purpose and reason not to choose them. And what I want to underline also is that under the GDPR, actually, it would be mandatory to perform a data protection impact assessment if the processing, in particular when there are new technology involved, is likely to result in high risk to the rights and freedom of natural person. And this is something relevant that I really would like to, I wanted to underline. But let's go fast to the last part of this masterclass, where we're going to see together what could be a possible design option for data privacy of a blockchain solution. These are some of the main ongoing technical development. Again, it will really depend on the specific use case. Some of them, some of this development could have the potential to anonymize public keys or transactional data. And so what I wanted to do is just to give you a non-exhaustive, of course, overview of some of the solutions that could be adopted. Each of these solutions, of course, comes with important trade-off that vary depending on the context, and that cannot be examined generically here. But really, I'd like to introduce them briefly. Then, first of all, the off-chain data storage. Well, depending on the specific blockchain use case, because of course that's where we need to start from, the use case. So it may be not necessary to store all transactional data on the blockchain itself. So such data could be stored in another off-chain database, and so be linked to the distributed ledger through a hash, a process which would have a number of advantage from a data protection perspective. And so where data is found, let's say after a data protection impact assessment to classify as personal data, then it should be kept off-chain and merely linked to the ledger through a hash pointer. So even if this doesn't change, of course, the nature of personal data, but it makes definitely easier to comply with the GDPR requirements. This off-chain storage would also enable the rectification, the erasure of personal data stored off-chain in appropriate database, and so will allow to have compatibility with two of the fundamental data subject rights that are the right to amendment and the right to erasure. So the first solution will be to storage personal data outside the blockchain. And this is probably the simplest way to prevent data from being shared on the blockchain. It's probably the easiest way. Now, zero knowledge proof. I know also that there was already a masterclass of zero knowledge proof. I'm very happy about it. I also took this masterclass. Actually, it was super interesting. So I won't say that much about this technique, but basically they can be used to provide, there is let's say binary true false answer without providing any access to the underlying data. So it is possible to provide a proof of statement, but without providing access to the information that is behind to the underlying data. And so this could be a very relevant cryptographic technique that allows someone, let's say, to produce proof of statement without disclosing the data that underline that statement. There are many different examples. Basically, where zero knowledge proof are used, the blockchain indeed only shows that a transaction has happened, but not which public key transfer will amount to the recipient. And so it has been really pointed out that zero knowledge proof and also another technique that we're going to see now, that is the homophobic encryption, have the potential to solve the conflict between data minimization and the verifiability of data between many parties. And that was stated also by the European Parliament in one of its reports, that actually this technique can be compliant with the data protection by design requirement. And we do also have, okay, this is very interesting because we're discussing about an editable blockchain. While blockchain, we say it's one of the main features is that it's immutable. So that looks really crazy on one side, but some actors are created this editable blockchain using the camel and hash function to edit, to remove, and to rewrite certain data. And this in order really to accommodate regulatory requirement. And of course, depending on the design of this solution, it will be possible to facilitate GDPR compliance. But of course, what has been stressed is that if we have a blockchain that can become editable, then why using this solution and why not using another form of distributed database? And so this really will depend on the surrounding government arrangement. Of course, there is a lot of discussion around it. The thing is that this editable blockchain use the camel and hash function, which allows basically for changing the underlying information without changing the outcome of the hash function. And so it is possible for change. What happens is this allow for changes to the underlying information on which the hash is already included on the platform, which make it possible to correct errors, especially human error or even fraudulent inaccuracy. And so again, this will allow the execution of data subject rights under the GDPR, especially the right to correction, to amendment, and the right to be forgotten. Then we do have the homophobic encryption. That is another advanced cryptographic methods. It's an advanced method of encryption that enable the computation of ciphertext. It allows for encrypted data to be subject to computation, generate an encrypted result that which the crypt produce the same result that if the computation had been done on unencrypted data. Again, this says a lot even about homophobic encryption, and there is no time now to go deep into this different technique. I just wanted to really show you some of the main ongoing technical development, but there are many others actually that are being explored. And so in these what we've seen in this model, first of all, if it's possible to have a blockchain privacy compliant application, and the importance to have to consider the data privacy aspect and have a data privacy impact assessment. And we have seen together, even if very quickly, some of the potential mitigation strategies that could be used to develop a blockchain compliant solution from a privacy perspective. And now some key takeaways that I would like to share with you. So we explored this technology solution that can meet challenges, some of the challenges posed by the data protection compliance risk. What I would like you to keep in mind is, of course, this technology right now could even be called as the best in class, but blockchain is a fast developing space that may offer really new technology option in few months, if not even days. So and also each approach is need to be considered the trade-off regarding complexity, cost, sophistication, and other aspects that all need to be taken into consideration. And also we need to consider which is the blockchain solution architecture in order to really put in place the right technique. And so coming to the takeaways, what I believe is important is, first of all, to find this trade-off between information transparency and privacy. So this is really key. The first takeaway on my side is that is important to evaluate is blockchain is really the right technology for the use case. So we need to start from the use case to see if this is the right technology to achieve the objective, the purpose of our project. And then analyze from an early stage the data privacy risk and develop a data protection impact assessment. Really, risk management is a tool. Another tool for risk management is represented by this data protection impact assessment. And this can be seen really as a general tool that can be used and also voluntary to document processes with regard to processing of data and also identifying mitigation strategy to implement recommendation, and so building data processing program in a more functional way, thinking on the risk. So which are the risks, which are the mitigation measures, how I do implement them. Then don't get personal. What does it mean? That if possible, avoid or limit personal data stored on blockchain. Because of course, one way, the easiest way to address laws and regulation related to personal data is to avoid putting any personal data on blockchain. And even if the broad definition for personal data across various jurisdictions are different, it is really challenges to avoid falling in their scope. Especially in blockchain, they use public-private key encryption to manage transaction among individuals. And so if possible, or even for use case that involved personal data, organization could consider to use privacy-friendly blockchain technique, such as the one we've seen already, so combine on-chain and off-chain storage in order to avoid storing personal data as payload on the blockchain, and also allow blockchain transaction to serve as mere pointers or other access control mechanism to more readily manage storage solution. And then don't get, keep it private, because anyone can join a public blockchain. It is impossible to ensure participants agree to necessary rules around the protection of personal data. And so start with a private network if that is possible. Of course, it's a first step on the path toward a GDPR compliant blockchain solution, because you all know that private blockchain are limited to specific user. This definitely diminishes the risk that someone on the node can gain access and discover private identifying information using information from the public domain. But again, private blockchain application can as well be risky based on the data obtained. So it really needs to be, the data privacy aspect really needs to be taken into great consideration. And so at the end, what you may need is to adopt a privacy by design solution, meaning to find really the best technique. And this is something that where it really will be need a joint effort. That's what is happened exactly in the project that I'm working on, is really have different people working on the blockchain platform, so legal, but also technical provider, business, say all together to discover the best solution from a privacy perspective. And then engage with regulators and stakeholders. I think this is another important aspect, because really we need guidance on blockchain, but this guidance needs to come from people that also knows, because they have developed blockchain solution, and so they can really talk to regulators and have guidance from them, or even regulation that can address the real distance from the industry and from the technical providers.